found. So otherwise, we have a valid value. So we could do something like this. Vals strings.split val. Okay, so strings.split takes a string as input and a delimiter. So we're going to say we want to split this string here, right? The value given to us by the authorization header. We want to split it on spaces. Okay. So next we can say if the length of vals does not equal 2, then again we can return an error saying, like, you know, maybe malformed auth header, right? Because we're expecting that the value of this key is two specific values separated by a space. The first should be API key, and the second should be the API key, right? The first should just be the string API key, and the second should be the actual API key. Okay, so if the length is wrong, then next we should probably check and make sure they typed this in correctly. So we can say if vals at 0 does not equal API key, malformed auth header, we could say malformed first part of auth header. Okay. Otherwise, we can just return vals at 1 and no error, right? Because by that point, we're sure that all this part was correct, and we're extracting just the API key. Okay, what did I screw up here? Errors.new. Oh, right. You're not supposed to capitalize errors in Go. That is a linting error. A stylistic error. Okay, cool. So now we've got the get API key function. We can go ahead and use this in our get user handler. So let's go ahead and grab that API key. So API key and error auth.get API key, and we pass in the HTTP headers. So r.header. Perfect. If there is an error, let's handle it. We can just respond with an error saying auth error. And 400, we should probably do like a 403. And in fact, now that I'm thinking about HTTP codes, creating a user probably should be a 201 instead of a 200. Like, you probably won't run into any issues for using a 200, but 201 is the created code. So it's like a little more correct if you're looking at it from kind of a RESTful HTTP standpoint. And then 403 is one of these kind of permissions errors. So that should be good. Okay, now that we have an API key, we can use our database query that we created, .getUser by API key. Again, we'll pass in the requests context and the API key. I haven't really touched on this yet. In Go, there is a context package in the standard library, and basically it gives you a way to track something that's happening across multiple Go routines. And the most important thing that you can do with a context is you can cancel it. So by canceling the context, it would effectively kill the HTTP request. I don't want to go too much into detail on how all of that works here. You could definitely go read up on it. But for now, just make sure that it's important to kind of use the current context. So every http.request has a context on it, and you should use that context in any calls you make within the handler that requires a context, just in case kind of cancellations happen. Okay, cool. That returns a user and an error. Again, if there is an error, let's use a better string here. Maybe couldn't get user. And this one, let's just go with a 404 or a 400 for now. Cool. And then we can respond with JSON. This time it will just be a 200 code. And again, we should cast that database user to the user model that we defined here, right? With the nicely formatted JSON tags. And that should be good. Okay, let's hook up our get user handler to our router. So here we'll do v1router.get. So same path /users, but we'll be hooking up the get user handler to the get HTTP method. So again, same path, different method. All right, let's test our new endpoint. First, I'm going to go ahead and rerun SQLC generate because I can't remember if I've done that. And then we'll build and run the server. Okay, with that running, let's head over to Thunder Client. And first, let's create another new user. So JSON body, let me minimize this a little bit. Let's create a new user. We'll call him Rand. And it'll be a post request. That looks good. Okay, response came back. Rand was created, and this is Rand's ID. We screwed something up. We're not responding with the API key. Let's go update that. So here in our model, I believe it's because we're not casting. So we need API key string JSON API key. And then here we need to do that conversion. So it's just getting dropped because we weren't setting the API key anywhere. Okay, let's rebuild. And we'll create a new user. Let's call this one Joe. Okay, cool. So Joe was created and it actually returned the API key. Perfect. Now let's go ahead and I'm going to create a new request. This one also to localhost 8080 /v1/users, but this one will be a get. And we're going to add some headers, or specifically one header, right? We're going to add our authorization header. And its value will be API key, and then the actual API key, which I just pasted in there. Okay, let's go ahead and run that. And it's returning Joe. It's good to test failure cases too. So let's just see what happens if we update this header, and let's just make something broken. Let's just remove a section of the API key and see what happens. Cool, we get a 400 bad request, couldn't get user, SQL, no rows in the result set. So essentially, users not found. Perfect. So we've got our users set up and our authentication system. Now it's time to actually get to some business logic, right? This is an RSS feed aggregator, so we need a way to store feeds. Let's create a new schema, or rather a new migration in our schema folder. This will be 003, we'll call it feed, feeds.sql. Now this is going to be a create table migration, right? We want to create a feeds table. So we'll do create table feeds. Now a feed, and the drop will also drop the feeds table. A feed has an ID, just like a user. It also has a created at and an updated at, and it also has a name. Like all of that is actually very similar. What's unique about a feed is it has a URL, which is text as well, that is unique and not null. And it also has a user ID, which references, it's a user ID is a UUID, which references user's ID. And we'll also add the on delete cascade. Essentially what this does is it says we have a user ID stored in our feeds table that references the ID of a user in the users table, right? So this is relational data. This is a relational database. Essentially what this means is if we try to create a feed for a user ID that does not exist in the users table, we'll get an error, which is what we want because we don't want feeds to be able to exist without a user who created them. And then this on delete cascade bit just says when a user is deleted, I want all of the feeds associated with that user to be deleted automatically. It will cascade and delete all of them. And let's run this migration. So I'm going to hop into the SQL schema directory. And from here, we can run Goose, Postgres, And grab my connection string. Again, we don't need the SSL mode stuff for Goose. Grab the rest of it. And up. Cool. Now over here in pgadmin, I can do a select star from feeds and make sure that that table exists with those fields. Next, we'll need a query to create a new feed. So I'm going to go ahead and copy this queries file, update it to feeds, and then we'll delete this one because we don't need it, and we'll create a create feed and insert into feeds. ID created at, updated at, name. There will not be an API key, but let's see. We need a name, URL, and user ID. Okay, name, URL, user ID. We won't be generating an API key here. Instead, all of these values, I think, will just be passed in from our application code. So 1, 2, 3, 4, 5, 6. We need 6 parameters for this function. 5 and 6. And then we'll just return the entire feed row after it's done being created. And then I'll just navigate back to the root of the project and run sqlc generate to create the code for that new query. Next, we're going to create a new handler that will allow users of our API to create a new feed. Here's the thing, that handler is also going to need all of this same logic that we have in the get user handler, right? We'll need to grab an authentication token or an API key from the authorization header, fetch the user, and then use that user in the handler. And rather than copying and pasting this, 10 lines of code into every handler that's authenticated, instead we're going to build some middleware to kind of dry up the code, right? Let's go ahead and do that. So I'll create a new file. I'm going to call it middleware auth.go, part of the main package. And here we're going to define a new type, and it's our own custom type. I'm calling it auth handler. And you'll notice it looks almost exactly like a regular HTTP handler. The only difference is that it includes a third parameter. It has a user associated with it. So if you think about this, it makes a lot of sense for any authenticated handler to accept 3 parameters where the third one is the authenticated user. Now, the problem with this auth handler type that we created is that it doesn't match the function signature of an http.handler func, right? Those functions with just the response writer and the request as the only 2 parameters. So what we're going to do is create a new function called middleware auth that works. It's a method on our API config, so it has access to the database. But its job is to take an auth handler as input and return a handler func so that we can, use it with the Qi router. Okay, let's implement that. The way this function will actually work is that we're going to return a closure. So we're returning here a new anonymous function with that same function signature as your normal HTTP handler func. The difference is that as we define this function, we'll have access to everything within the API config. So we'll be able to query the database. So we can basically just go rip out the code from our get user handler and paste it in here. Right, we're going to go get the API key from the request, well, from the request's headers at least, and then we can go ahead and grab the user using that API key. Right, so we'll have access to the user here in the function. Finally, all we need to do is run the handler that we were given with the response writer, the request, and the user. Right? So by the time we get to actually calling the auth handler, we're able to give it an actual user from the database. And this is really great. Let me show you why. So now that the middleware auth function exists, we can remove all of this code from the get user handler. We can update the get user handler to accept as input a database user. User, database.user. Look at how clean this function becomes, right? Now it's literally just one line. Cool. And now to hook it up, you'll notice we have an error over here. We just need to call our middleware auth function, API CFG dot middleware auth. We call this function to convert the get user handler into a standard http.handler func. I kind of moved fast through that. Hopefully it all makes sense though. Basically, we're just calling the middleware auth function first to get the authenticated user, and then we're calling that callback, the get user handler. The nice thing is now we'll be able to reuse that middleware across many different HTTP handler functions. So now let's create the create feed handler. I'm gonna go ahead and just copy this handler user, change it to handler feed. And for now, we just need a create function. So I'll delete this get, and we'll call it handler create feed. And remember, it's an authenticated endpoint, so we can have it accept the user directly. So user database.user. We know who's creating the feed by the time we get to this function, which is awesome. All right, in order to create a feed, use our new create feed function, which takes create feed params. And create feed params have ID, created at, updated at, name. That's all the same. The difference is a URL and a user ID. So URL and a user ID, which is a UUID, which actually exists already on the user object. So we can just do user.id. Okay. What do we want as input? We need a URL. So we also are going to want a params.url. So we want the user that's creating a new feed to be able to just send us a name and a URL, and we'll go about creating the entire feed object in the database, or feed row in the database. So this is what our parameters should look like. What error am I running into here? Cannot use API CFG.create feed. No new variables on left side of, that's odd. Create feed should return a feed. Let's take a look at that definition. Yeah, it does return a feed. What am I messing up here? Oh, first of all, that shouldn't be a user. That should be a feed. Okay, that's the problem. I was trying to overwrite the database.user type with a feed type. That won't work. Okay, so we're creating a feed. We're generating a new UID. That's great. We're using the current time. Perfect. This is getting messed up. Variable of type UUID.UUID as UUID.null UUID. Ah, okay. I see the problem. The create feed params accept a UUID.null UUID. That's a problem. We don't ever want the null UUID type from the UUID package is a nullable UUID. But we don't want it to be nullable because we expect that every feed will be created by a user. So let's go update our I think it's is it our migration? Let's go look. Schema, feeds. Yeah. User ID, UUID, not null. Cool. It doesn't need to be unique. A user can have multiple feeds, but it should never be null. All right. With that, we're actually going to need to go rerun our migration. So SQL, schema, and we'll do a down to drop the table, down, and then back up to create the new table with the proper schema. And then we should rerun SQL C generate. Okay. Did that work? Create feed params. Looks like that error is gone. It's now just a UUID type. Perfect. Now, at this point, we have a valid database feed. We should probably update this error so that it actually says feed. And we want to return it in our HTTP response. Trouble is, remember, we don't want to just directly return the struct. Let's go create a new model for a feed. So we'll do type feed. And then I'm going to go just copy the types from here, and we'll use those. And we'll make our own JSON tags for the type. User ID, URL, name, updated at, and created at. Okay. And then we'll want a, what is it? Database feed to feed. And we'll return a feed. All of this should be pretty straightforward. And again, this just gives us more control, right? Now we, in our code that's not generated by SQL C, are able to define, what the shape of the response will look like. If for whatever reason we needed to store some data in the database but never wanted to respond with it in our JSON API, we could make those changes here in this struct. Okay, so now we've got database feed to feed. We'll call that. And now we should be good to go. All right, let's test out our new handler. So I'm going to rebuild our server and run it. And over in the Thunder client, let's see. So we just created a new user, Joe. So we have our authentication key here, or our API key. Going to do a new request to http:/localhost 8080/v1/feeds. Now that I type this out, I realize that we never hooked it up. Let's go hook up that feed. So feed handler create feed. We need to go paste this in to the main function. So this one will go under /feeds. Because we're creating a resource, we're going to use a post request. Handler create feed. Okay, that should be hooked up now. Let's restart our server. And over here, again, I need to grab that API key. All right. What do we want here? Post request, localhost 8080 v1 feeds. We do need to authenticate again, so query headers, authorization, API key, paste in that API key. Okay, what do we send in as the body? Let's take a look at our handler again, a name and a URL. Okay, so name. Now remember, this is not a person. This is a feed, right? And a feed is a URL that kind of links to an RSS feed out on the internet. So this one, I'm going to put just Lane's blog, and then the URL is going to be https://wagslane.dev/index.xml. So in case you're not familiar with what an RSS feed is, let me just show you really quick. I'm here on my blog, wagslane.dev, and if you click RSS up at the top, it'll take you to my RSS feed. Now, every RSS feed will have a different URL. It's kind of up to the author of the blog or the podcast what that feed URL is, but you can usually find it by poking around on their website. So in my case, it's just wagslane.dev/index.xml. And it will look something like this if you open it up in a browser. It's basically this structured XML document that describes what each post on the blog says, at least from a high level. It'll usually have something like a link to the post, maybe a short description, basic stuff like that. Again, podcasts also work on this same RSS structure. So for testing, you can use my blog, or if you know of any other RSS feeds out on the web, you can use them. So now that I've pasted in that URL, let's go ahead and create that feed. And what do we get back? Cool. The feed's got a new URL, created at, updated at, the name and the URL seem to have persisted correctly, and that is the user ID associated with the API key that we use to create the feed. Next, we're going to add the ability for any user to get all of the feeds in the database. This is not an authenticated endpoint. Okay, so we need a new query. I'm going to go ahead and use the same file. This query will just be called getFeeds, and it will return many rows instead of just one. All right, and this one will be select star from feeds. Super simple query here. We're just going to go grab all the feeds and return them. Okay, from there, we should be able to SQLC generate. And let's go hook up that handler. I'm going to use the same handler feed file, but this one will be a little bit different. We're going to call this one handler get feeds. It's not authenticated, so we don't need to pass in a user. And it doesn't even take any parameters, right? It's just going to go get all of the feeds. So API cfg.db.get feeds. And the get feeds function, if you remember, we just wrote it in SQL. It doesn't take any parameters. And it just returns all the feeds that are currently in the database. So this error should say something like, couldn't get feeds. Cool. Now we need to return all of the feeds. This is not a single feed. This is now a slice of database.feeds. So not only do we need to return them, but we need to actually convert them. So let's go update our models a little bit. Let's create a new function. This one will be database feeds to feeds. And the difference is it will accept a slice of database feeds and it will return a slice of feeds. Let's do this. Slice feed, we'll create a new empty slice of feeds, and then for db feed range db feeds equals append feeds database feeds or database feed and return feeds. Sorry, we don't want to append it directly. We have to call our conversion function. Okay. So this function will just iterate over all of the database feeds one by one, converting them into our new feed structure and then returning them. Cool. Now here we can use that function to do that mapping. Great. Let's hook up this handler. So in main.go, we'll create a new entry here. This is going to be a GET request, and it's not authenticated. It'll be handler get feeds. Cool. Let's regenerate. I can't remember if I generated MySQL C, so I'll do that. Couldn't hurt. And then we'll build and run the server. Okay, with that running, let's go ahead and create a couple more RSS feeds. So here, update the body of my request. Sorry, I'm so zoomed in so that you guys can see, and it just makes it hard. No, this was to create users. This is users. Here's feeds. Okay, let's just add the same URL with a couple. Well, no, we can't add the same URL. Let's just use some garbage URLs just to test. Okay, that created properly. Now let's test our new endpoint. This one is going to be a GET request to feeds, and we don't need to add any authentication information. Okay, run that. Awesome, this looks good to me. We've got an array at the top level and then two feed objects, one for garbage blog and one for lanes blog. So it looks like everything's working. So we've given users a way to create feeds and a way to query all of the feeds. Now we're going to give users a way to follow specific feeds so that they can see kind of an aggregated view of all of the feeds that they care about on the system. Okay, so let's go ahead and add a new migration. We need a new table. So this will be the fourth migration, and we'll call this new table feed follows. And this table is just going to store the relationship between a user and all of the feeds they're following. So it'll be a many-to-many kind of table of user IDs to feed IDs. All right. The table is going to be called feed follows. So create table feed follows. Every feed follow, like every other record in our database, will have an ID, a created at, and an updated at. But its unique fields will be a little bit different. First, it's going to need a user ID, which is, oh my gosh, why can't I type? Fingers are the wrong place in the keyboard. So a user ID is a UUID. That can be, it doesn't need to be unique, but it does need to be not null. And then we need a feed ID, also a UUID, not null. And then we're going to create a unique constraint on the combination of user ID to feed ID. So unique user ID feed ID. So again, this constraint is going to make it so that we can never have two instances of a follow for the same user feed relationship, right? You as a user can only follow a certain feed once. You can't follow it twice. That doesn't really make sense, right? So we're going to ensure that that's unique. Also, I missed a couple things here. The user ID should reference, so references the users table ID field, and on delete will cascade. So if a user is deleted, we're going to go delete all of the data about what feeds they're following. And then this one's going to be very similar, except it references the feeds table with its ID. And again, if a feed gets deleted, then we'll go delete all of the following data related to that feed. Cool. Okay, let's go ahead and run this migration. So I'm going to go back up into the SQL, or I should say back down into the SQL schema directory. And from here, I'll need my connection string, do goose, Postgres, connection string. I didn't grab the whole thing. Let's try that again. All of that, goose, Postgres, up. Cool. Feed follows databases, or feed follows table is there. So now we need a way for users to follow feeds. All right, let's go ahead and go create that. So I'm going to copy and paste the feed handler file, and we'll call it handler feed follows. And update this. So handler create feed follow. So remember, in order for a user to follow a feed, all we need to do is create a new feed follow record with that user feed relationship. Okay, this is an authenticated endpoint, right? We need a user and we need them to be authenticated, have passed an API key, right? And let's see, what do we need them to give us as input? I think all we need is a feed ID, right? They just need to tell us which feed they want to follow. So a feed ID is a UUID. All right. And now we should be able to create feed. Oh, we never made the SQL query. What am I doing? I'm getting way ahead of myself. Let's go add that query quickly. So feed follows. And to start, we'll need a create feed follow. Okay, what's in a feed follow, right? Got all of these fields, and I think, yeah, we're just gonna have them all passed in directly. That seems like the easiest way. So insert into feed follows, ID, created at, updated at, user ID, feed ID. That's 5 parameters, right? 1, 2, 3, 4, 5. Cool, that looks good. Now I should be able to go back and run sqlc generate. Cool. Now I should have a create feed follow function with create feed follow params. All right. It accepts a user ID and a feed ID. So the user ID is just the authenticated user. The feed ID is going to be passed in as params, right? Cool. Couldn't create feed follow. Don't need a get handler quite yet. And then we're going to just need to make that mapping function as well for feed follows. So in our models file, I'll create a new feed follow struct, and it's going to have a user ID and a feed ID. And a new function, database feed follow to feed follow. All right, db feed follow.id. By the way, I'm not using GitHub Copilot in this video just so that you can just so you can see more of my thought process. But I typically do use GitHub Copilot, and it makes this kind of function just like way faster to write. It would guess this kind of function almost perfectly. So just so you know, I do recommend those kinds of tools to speed up the development process. I'm just not using it right now, so that you can see how I think through, architecting this application without all the AI prompts getting in the way. Okay, now we should be able to database feed follow to feed follow, and we're gonna be clear that this is a feed follow, not a feed, and that goes there. Perfect. All right, let's hook this up. So we're going to need to go into main.go, v1 router .post, because we're creating a resource, /feed follows, and this is an authenticated handler create feed follow. Okay, let's test this new endpoint. So we'll build and run the server. And we'll need a new request. This one will be kind of similar. It'll be a post request to the feed follows endpoint. And we're going to need to authenticate. So let's go grab some authentication information. Let's see, get users. Let's go ahead and send this. Couldn't get users, SQL no result. Okay, I need to figure out what users I have available to me. Oh, that's right. We changed this API key. We wanted it to break. Let's go create a new user. We'll make a new one called Billy. And there's Billy's API key. Cool. We've got some feeds, but our feed follows need an auth section. Sorry, in the headers, we're doing it manually. Authorization, API key, there's Billy's key. And then in the body, we need to pass in the ID of the feed that we want to follow. So let's do a get on all of the feeds, and we can follow either of these. Let's follow Lane's blog. There's our feed ID. Paste that in there and create. Amazing. New ID for the feed follow. There's the user ID, the feed ID. What happens if we try to recreate it? Cool. Couldn't create feed follow, duplicate key value, violates unique constraint. That's what we'd expect, right? We shouldn't be able to follow the same feed multiple times. We're already following it. We already have a record indicating that we are following it. Everything appears to be working just fine. Next, let's give users a way to see all of the different feeds that they are currently following. So we'll do get feed follows. It will return many. And the query will be select star from feed follows where user ID equals $1. Right? So get all the feed follows for a given ID. Let's get that hooked up. Need to run SQL generate to create that query. And then down here, we'll create a new handler. This handler will also be authenticated, but it's going to be get feed follows. Have the user. We don't need any parameters here. And we're just going to call get feed follows. And we'll just need to pass in the user's ID. Couldn't get feed follows. Cool. Now we've got a list of feed follows, or a slice of feed follows. So we're going to need to convert an entire slice. So again, down here, we'll write this type of a function. It's going to be database feed follows to feed follows. All right. Lots of copying and pasting here. Feed follows. Okay, so now we have a way to convert an entire slice of database feed follows to our own struct. That looks good to me. There, feed follows. Ooh. Okay, cool. Now we have a handler for getting feed follows. Let's go ahead and update this. So we need a new v1 router dot get slash feed underscore follows. Middleware auth. Get feed follows. Perfect. All right, let's give that a shot. So we'll build and run again. And now, let's see. So this is the request that we used to create. So let's grab. Oh, so hard working on such a small screen. Let's grab our API key and create a new request. /v1/feed follows. It's going to be a GET request. It does need to be authenticated. Okay. Let's see if that works. Cool. We got the one feed back that we're currently following. Finally, we need a way to unfollow feeds or to delete feed follows. So let's create a new one. A new query. We'll do delete feed follow. Now, this one is going to be our first query that doesn't actually return anything. It's just going to be an execute, right? We're not returning one record. We're not returning many records. We're returning no records. We're just going to run a SQL query. So it's going to be delete from feed follows where ID equals $1 and user ID equals $2. Now, it's important to point out that we don't actually need the user ID here for this query to work, right? The ID is already a unique identifier. The reason I'm tacking on this user ID is because this will prevent someone who doesn't own a feed follow from trying to unfollow a feed on behalf of somebody else. That makes sense. If for whatever reason another user got access to, let's say if for some reason user B got access to the feed follow ID of user A, if we didn't have this check here, then that user who hijacked a feed follow ID would be able to like unfollow like force the other user to do an unfollow, if that makes sense. This ensures that only the user who actually owns the follow record can execute the unfollow command. Hopefully that makes sense. Okay, from here, let's just go ahead and generate that and go hook it up to a new endpoint. So we'll do handler, delete, feed, follow. Now, this one's going to be a little different in that it is authenticated, but we need to get a feed follow ID and delete requests. So like HTTP delete requests, the delete HTTP method, they don't typically have a body in the payload. It's possible, but I would argue it's not super conventional. It's a little more conventional to pass the ID in the HTTP path. So it's going to look something like this. view_router.delete feed follows / feed follow ID. And then this will be handler delete feed follow, right? So we want the feed follow ID dynamically passed in the path of the request. So the question is, how do we grab this feed follow ID in our handler itself? Well, the Chai router has, or Chi, I'm never going to say that the proper way. The Chi router has a, I think it's is it URL? Let's see, URL parameter. That's the one. URL parameter function where we can pass in the request and a key. And in this case, it's going to have to match. So feed follow ID matches whatever we type in here between the open and close brackets. Okay, and that's going to return a string. So this is the feed follow ID string. Great, we're going to take that and we're going to parse it into a UUID. So we'll do UUID.parse. And that will return a feed follow ID and potentially an error. If the error does not equal nil, we'll say couldn't parse feed follow ID. And that will be a 400 level error. Perfect. Okay. From here, we should be able to do API cfg.database.delete feed follow. And we need to pass in the request context and the feed follow params. So database.delete feed follow parameters. It takes an ID and a user ID. So the ID of the feed follow we just parsed, and then the user ID comes in with that user object because this is an authenticated request. Cool, and that should return just an error. Right? Oh, and it's just giving me yellow squigglies because I need to handle the error. So couldn't delete feed follow. Perfect. What do we respond with here? I guess we have a couple different options. The simplest thing would just be to respond with like an empty JSON object, I guess. What matters to the client is probably the 200 response code. So we could, like, for the sake of simplicity, just so we can use our respond with JSON function, we'll just return an empty JSON object. Alternatively, maybe we could return an object that says like message, unfollow successful or something. But it doesn't matter too much. I think as long as it's a 200 level code, we're pretty much good to go. Okay, and that's already been hooked up. So let's go ahead and test it. Can't remember if I generated. Let me do that again, and then we'll restart the server. And take a look. Okay, so this was our endpoint. It's returning the feeds that we're currently following. Let's go ahead and delete this feed follow. So we need new request. This is going to be a delete request. We're going to unfollow a specific ID. We're going to unfollow this. We're going to delete this feed follow. Right? Feed follow with that ID. And the headers, we do need to be authenticated as the same person. So authorization, same API key. Okay, let's run that delete. We got a 200 response. Now let's go do a get and make sure that it's gone. Yep, empty list or empty array. We're good to go. Okay, we've built out the majority of the CRUD section of our API, but we haven't built the most interesting part, which is the part of the server that actually goes out and fetches posts from the different RSS feeds that exist in our database. Again, the whole purpose of this server that we're building is so that it can keep track of all of these different feeds in the database and then go out periodically and actually download all of the posts that are on each individual feed. So for example, we have a feed for my personal blog post. This server will actually go out to my blog every, 10 minutes and check to see if there's a new blog post to download and store in the database. So the first thing we need to do is update the feeds table to have one more column. We need a new column called last fetched at, and it's just so we can keep track of when we last fetched the posts for a given feed. So let's go ahead and add that. We'll need a new migration, and it will look kind of like this migration. It's going to be our 5th migration so far. It's going to be on the feeds table, and we're going to be adding the last fetched at field. Okay, so alter table feeds, add column last fetched at, and this one is going to be timestamp, and it will be nullable, so we don't need a not null constraint. In fact, that's it. It's okay. Like, we don't need to specify any defaults. That should be it. And then as far as the down migration goes, we'll just be deleting or dropping the column from the feeds table. Okay, cool. Let's run that migration. So Goose, Postgres. Perfect. So we don't need to update the create feed function. We want the last fetched at field to default to null. So no changes are necessary there. But we do need a new query. This one's going to be called get next. Oh my gosh, get next feed to fetch. Can't type today. Get next feed to fetch, and it will return a single row. And this one should say select star from feeds, order by last fetched at, descending nulls first, limit 1. Whew, okay. So the purpose of this function is to go get the feed that next needs to be fetched. Like, we need to go get posts for this feed next. And the whole idea is, first, we want to go find any feeds that have never been fetched before. Those need to take priority. After that, if every feed has been fetched, then we want to go find the one that was fetched the longest ago, like the farthest in the past, right? So we're ordering by last fetched at, nulls first, in descending order. Actually, scratch that. We're going to want to do ascending, right? Ascending would put the lowest, the smallest timestamps, right? The ones further in the past at the top, and then ascend into the present. Okay, so order by last fetched at, ascending, nulls first. Perfect. Okay, just to make sure that my SQL code is valid, we'll generate that. Looks good. Okay, next we need one more query. This one will be called mark feed fetched. Mark feed, I guess, as fetched. This is the one we'll call after we fetch a feed to say that we fetched it. And we'll return the updated feed. Okay, so it's going to be update feeds set last fetched at equal to now, and updated at also equal to now. So we haven't really gone over this, but the updated at and created at fields are mostly for auditing purposes. It's pretty standard practice to set these fields on basically every record in an SQL database, just so you can see when they've been created and updated. It's kind of, again, auditing purposes. Okay, where ID equals $1 and returning star. Okay, so we update the feeds, we set the last fetched at and the updated at to the current time for the given ID. That looks good to me. Let's go ahead and generate that. Perfect. Next, we need a way to kind of take an RSS URL or a feed URL and parse it into an actual response body. And in this case, we're going to represent it as a struct. Let me show you what I mean. So let's create a new file. I'm just going to call it rss.go. And it's going to be part of the main package. And we need a new function. And we're going to call it RSS to, or actually let's call it URL, URL to feed. Okay. And it's going to take as input a URL, which is just a string, and it will return a new type. So we need to specify the new type. Type RSS feed. It will return both an RSS feed and potentially an error if there's something wrong with the request that it's making. Now, that RSS feed struct that we just created is going to represent basically this giant document here, right? So if you go to wagslane.dev/index.xml, which is a valid RSS feed, then you'll see this giant document. And really, you can think of RSS as just a structured data in XML format. And XML is just kind of like crappy JSON. So the way we parse XML in Go is very similar to the way we parse JSON. Let me show you what I mean. I've done the dirty work of scanning all of the valid values in that big RSS document. And I found that basically these are the keys for the RSS entries in my blog. So RSS is kind of a standardized set of keys within XML. And basically what I'm saying is these are the keys that we care about, right? At the top level of an RSS feed, we expect a channel key, right, in the XML document. And we expect a channel to have a title, a link, a description, a language, and then a slice of items. And then items are kind of these nested objects that each have their own title, link, descriptions, and publication dates, right? And each item is a new blog post. And if you're asking how I came up with those names of all of the different keys, it's because I went and looked here in this document. I saw, okay, at the top level, we have a channel, right? And then we have this entry with a title, a link, a description, right? So I just kind of manually looked through this document and found all of the stuff that I wanted to parse out. So let's fill in the rest of this URL to feed function. So first, we're going to need an HTTP client. I'm just creating a new client using the HTTP library. We'll set it to a timeout of 10 seconds. If it takes more than 10 seconds to fetch an RSS feed, we don't want that feed anyway. Probably broken. Okay, then we can use that client to make a GET request to the URL of the feed. And that's going to return an HTTP response and potentially an error. If there's an error, we'll just return, let's just do, for ease of use, I'm going to make this a pointer to an RSS feed, so we can just return nil and the error. Cool. If everything's okay, then we're going to defer a close on the resp. Sorry, it's not the close function. It's resp.body.close. Okay, and then after that, we want to get all of the data from the response body. So it's going to be io.readAll. We want to read everything from resp.body. And that comes back as a slice of bytes and an error. Okay, this slice of bytes, we want to read into this RSS feed. So dealing with XML in Go is very similar to dealing with JSON in Go. So it's actually going to be XML dot unmarshal, pass in the data and a pointer to where we want to unmarshal the data. So actually I need to create an empty struct. We need RSS feed is an empty RSS feed struct. Then we'll unmarshal into that location in memory. That will return an error. If everything goes well, then we can just return the new populated RSS feed. Perfect. Now, as I type this out, I'm already kind of dissatisfied with this pointer solution. I don't think that needs to be a pointer. I think we should just return empty structs. Either way would work. I think this is a little cleaner though, because it means the user of this function, us, right, will get an actual RSS feedback and not a pointer to an RSS feed. Okay, let's go ahead and test this really quick. I'm just going to do a little kind of hacky thing. Just right at the top of main, I'm going to call URL to feed and give it the URL of my blog. So wagslane.dev/index.xml. That should return a feed and an error, right? And then if error not equal nil, blog.fatal error. Otherwise, I want to just print out fmt.println. Let's just print out the whole feed. It'll be disgusting, but at least we'll get to see if it kind of worked. Okay, let's build and run that. There we go. Cool. So if you kind of scroll through this, you'll see it looks like, I mean, there was no errors. And then it looks like we properly, at least, you know, at first glance, looks like we properly filled out that struct. It's kind of just dumping all of the data. So now that we've done a sanity test on our URL to feed function, let's go write the actual scraper. I'm going to create a new file. Just call this scraper.go. Again, in the main package. Okay. The scraper is a long-running job. So this scraper function is going to be running in the background as our server runs. So let's name it something like start scraping. And let me split up these parameters so we can actually see what we're dealing with here. So it'll take 3 inputs: a connection to the database, a number of concurrency units. I guess the best way to think about this is how many different Go routines we want to do the scraping on, and then how much time we want in between each request to go scrape a new RSS feed. Cool. And it shouldn't return anything because this is going to be a long-running job. Now, because this worker, this scraper, is going to be running in the background of our server, I think it's really important that we have good logging that kind of tells us what's going on as it's happening. So when we start scraping, I'm going to do a little log message here. So log.printf will say scraping on %v Go routines every %s duration. Pass in the concurrency and the time between requests. Cool. After that, we need to figure out like how we're going to make our requests on this interval. And there's a really cool mechanism in the standard library in Go called a ticker. So we can create a new ticker using the standard library. So time.new ticker, and we give it a duration, in this case, time between requests. And it responds with a ticker. And then we can use a for loop to execute the body of the for loop every time a new value comes across the ticker's channel. So the ticker has a field called C, which is a channel where every kind of, let's say that, you know, time between requests was set to 1 minute. In that case, every 1 minute, a value would be sent across the channel. So by using this syntax here, we could say run this for loop every 1 minute. And the reason I'm passing in an empty initialize and an empty middle section to the for loop is so that it executes immediately the first time. So the very first time we get to line 17, the body of the for loop will fire immediately, and then it will wait for the interval on the ticker, if that makes sense. If we just did this, if we just did, what is it? For range ticker.c, then it would actually wait for the minute up front. But I want to do it once immediately. It'll make it easier to debug and work with. Now, at this point, I realize that I've made a mistake. The purpose of this concurrency parameter here is to, indicate to the start scraping function how many Go routines we want to use to go fetch all of these different feeds. And the whole point is that we can fetch them at the same time. So that means that each time that this ticker fires, we need to be potentially going out to the internet to fetch 10, 20, 30 different RSS feeds and download all of their blog posts at the same time, which means we'll actually need to be able to grab a multiple number of feeds. We'll need to grab more than just one at a time. So rather than get next feed to fetch, let's change this to get next feeds to fetch, and we'll have it return many. And then rather than limiting to one, let's limit to $1. So we can actually pass in how many feeds we want as a parameter to this function. Okay, then we should be able to regenerate that. And we should, we're not even using the function yet. So, okay, so that was actually the perfect time to do that. Okay, let's fill out the body of this for loop. So every interval, time between requests, we want to go grab the next batch of feeds to fetch. So we can just call that function that we just wrote, database.getNextFeeds to fetch. It takes a context and a limit. So the first thing, we'll just use context.background. So again, I haven't gone into a ton of detail on the context package, but basically context.background is like the global context. It's what you use if you don't have access to a scoped context like we do for our individual HTTP requests. Okay, so that'll work for now. And then we also need to pass in a limit. So we'll just cast int 32 and the limit, or the concurrency. And that should return some feeds and an error. If there's an error, we should probably print something. Now notice I'm continuing here. That's because this function should always be running as our server operates. Like there's no time in which we want this function to ever stop. So if I returned here, that would be a problem. It would actually stop scraping completely just because maybe, I don't know, our database connection was down temporarily. So for now, we're just going to log and continue. Now that we have a slice of feeds, let's write some logic that goes and fetches each feed individually. And importantly, fetches each individually at the same time. So we're going to need a synchronization mechanism. I'm going to use a wait group. So the standard library has this awesome thing called a sync.waitGroup. Then we can iterate over all of the feeds. So for feed, range feeds. Okay, so the way that the wait group works is anytime you want to spawn a new Go routine within the context of the wait group, you do a waitGroup.add. And you add some number to it. So here I'm iterating over all of the feeds that we want to fetch on individual Go routines, and I'm going to add 1 to the wait group. Then at the end of the loop, I can do a waitGroup.wait. And within the loop, I can spawn a new Go routine. So we're going to go do some function. In fact, I guess I should just name it kind of what we'll be doing. Let's call it scrape feed, go scrape feed. And here we're actually going to pass the wait group in as one of the parameters. And within scrape feed takes a wait group, which is a pointer to a sync wait group. Within this function, we'll defer a wait group dot done. Okay. So what happens here? Basically, we're iterating over the all of the feeds on the same Go routine as the start scraping function. So on the main Go routine. On the main Go routine, we're adding 1 to the wait group for every feed, right? So say we had a concurrency of 30, we would be adding 30 to the wait group. Now, we'll be spawning all of these separate Go routines as we do that. And when we get to the end of the loop, we're going to be waiting on the wait group for 30 distinct calls to done. So done effectively decrements the counter by 1, right? Done decrements the counter by 1. So we're adding 1 every time we iterate over the slice, and then we're calling done when we're done actually scraping the feed. So what this does is it allows us to call scrape feed at the same time 30 times. So we go spawn 30 different Go routines to scrape 30 different RSS feeds. And when they're all done, line 35 will kind of execute and we'll move past that. Until they're before they're done, we'll be blocking on line 35, which is what we want to do because we don't want to continue on to the next iteration of the loop until we are sure that we've actually scraped all of the feeds. So we've sort of stubbed out this scrape feed function. Right now it doesn't do anything other than call wait group.done. Let's actually go scrape some feeds. So it's going to need access to a database connection. And it's also going to need a specific feed to go fetch. So feed is a database.feed. Cool. And then here we can pass in database and feed. Great. The first thing scrape feed should do, and keep in mind we're deferring the wait group.done. So this will always be called at the end of this function. The first thing we should do is mark that we've fetched this feed or that we're fetching this feed. So it's going to be database.mark feed as fetched. We can just use the background context again. And we need the ID of the feed. So feed.id. Cool. That should return an error if there was an error, I think. Oh, it also returns the updated feed. I don't think we care about the updated feeds. I think we can ignore that. Say if error is not equal nil. Now keep in mind, we're not returning anything from this function. Remember, we're calling it on a new Go routine. So there's nothing to return here if there's an error. Instead, we'll just log there was an issue. And return nothing. And next we need to actually do the heavy lifting, which is to go out and scrape the feed. So we already wrote our URL to feed function. Let's just use that. So URL to feed, and we'll pass in the feed.url, and we should get back an RSS feed and an error. And if error does not equal nil, error fetching feed. And we'll return there. Otherwise, we need to do some logging. So in the future, what we'll do is instead of iterating over all of the items in the RSS struct that we get back and just printing them to the console, we'll be saving them into the database. But for now, just so that we can test our scrape feed function, we're just going to log all of this to the console. So we're going to log each individual post, or rather that we found a post, and then how many posts we found. The last thing we need to do is go hook up this start scraping function to our main function so that it actually starts. Okay, so start scraping takes database concurrency. Actually, I'll just open this. My screen's too small to be working in 2 tabs at the same time. Okay, we're going to need to call it before listen and serve, because remember, this is where our server kind of blocks and waits forever for incoming requests. So we should probably call it, I don't know, right here. Seems like a good spot. So it's just a function, right? Yeah, it's not a method. It takes database concurrency and time between requests. Okay, So we go start scraping. Remember, we want to call it on a new Go routine so that it doesn't interrupt this main flow. Because remember, start scraping is never going to return. It's a long running function. This is an infinite for loop. Okay. It needs a database connection. So we'll actually need to save this in a new variable so that we can use it in the API config and in the start scraping function. Next, we need the concurrency. Let's just start with 10. Seems good. And then time between requests, let's do time.minute. Perfect. I went ahead and added a second RSS feed. So let's go ahead and check the database and see what feeds we have currently. So I've got Lane's blog and the boot dev blog. So there's two. Now remember, we were setting a concurrency of 10, so we should definitely be able to fetch both of these blogs at the same time on the first iteration of that loop. If we, say, deployed this to production and allowed users to start creating feeds, maybe we'd get up to 100, 200, 400 different feeds in here, then we'd only be fetching 10 at a time, right? Just so we understand how that mechanism works. But for now, this should be good enough to test. I'm going to update our logs just a bit so that we can see which blog each post is from. So found post, item.title, on feed, feed.name. Okay, let's go ahead and run that. Found post, the properties of pointers in Go, on feed, boot dev blog. Perfect. So we kind of scroll up. We should be able to see some. The boot dev blog has way more blog posts than my personal blog. Here it is. Here's some Lane's blog stuff. Okay, so that looks like it's working. We should be able to move on to the next step now, where we'll actually save these blog posts into the database rather than just logging the titles to the console. We're going to need a new table in our database. So let's start there. We'll call it posts. So the purpose of this table is to store all of the posts that we are fetching from all of the different RSS feeds. Okay. What am I doing? This is queries. We need to start with a migration. So let's grab this. We'll make it 006 posts.sql. All right, goose up is going to be create table posts. What goes in a posts table? We are going to need an ID, a created at, and updated at. That pretty much never changes. What else does a post have? Well, it has a title. Title. Is that text not null? That makes sense. Posts also typically have a description. Text. I'm going to allow that one to be nullable. I think it's okay if a post is missing its description. Posts also typically have a published at date. So published at, which is a timestamp. Should we allow that one to be nullable? No. No, let's make that not null. What else does a post have? It has a URL. A URL should be not null for sure. I'm also going to say that it should be unique. Unique. I don't think we ever want to store the same post in the database twice. There's no point, right? If we have a post, I don't see why we would need it a second time. So let's go ahead and make that one unique. And then lastly, let's just put in a feed ID. And the feed ID is going to be a UUID that we're going to want it to be a reference, so references, feeds ID, right? And that's going to be, does that need to be unique? It doesn't need to be unique, but it should be not null. We should always have the feed ID of a post. And let's here put on delete cascade. If we delete a feed, we'll cascade and delete all of its posts. And I forgot to put the type here. So URL text not null unique. Okay, that looks good to me. Let's go ahead and run our migration. So it's going to be, we need to cd into SQL schema and run goose Postgres. We'll need this connection string up. Perfect. Next, we'll need a couple of queries to interact with this table. The first one's going to be just a way to create a post. So let's do posts, and we'll do create post, return one thing. And we'll just kind of be inserting a bunch of stuff, I think. Let's take a look at the post table. So we've got ID, created at, updated at. Let me just grab this so I don't forget it. Okay. So insert into posts, ID, created at, updated at. We also have, we have a lot of stuff. So I'm actually going to start spacing this out a little bit. Created at, updated at. It's going to be a title and a description. Published at, URL, and a feed ID. Okay, and the values 1, 2, 3, 4. How many do we got? Just 8. 5, 6, 7, 8. Returning star. Straightforward, right? Insert into posts, all of these fields, no fancy logic. That should be good. Okay, let's run sqlc generate to add that function to our internal package. And then we just need to go use it. So down in the scraper now, instead of just logging all of these posts to the console, let's save them to the database. I'm going to leave this log message. It just says feed blank collected blank posts found. So that'll just log all of the different feeds we were collecting, but each individual post, I think it's wasteful and kind of busy to log everything. So we're not going to do that. Instead, we'll just call db.createPost, context.background, and what does it take? Create post params, database.create post params. Okay, cool. I kind of like how sqlc breaks down the parameters into a struct. It makes it pretty simple to work with. Okay, we've got an ID, created at, updated at. Okay, ID is just going to be a new ID. Created at, updated at, that'll just be time.now. .utc. What's next? Title, description, title. Item.title. I just realized now that I'm not putting the field names. It's kind of embarrassing. Okay, title, description. Do they not have a description? What does an item have? Let's take a look at an item. Items have title, link, description. Yeah, it does have a description. What am I messing up here? Cannot use item.description variable of type string as sql.nullString. Ah, right. Okay. So we need to do sql.nullString. A null string has the string itself and whether or not it's valid. So we just put in the string, and then we say it is valid. String.valid is a Boolean true. Although, actually, this is a problem, right? This is a problem because if item.description is blank, if it's an empty string, we're going to be putting in an empty string and saying that it's there, even though it's not. So let's not do this. Let's do something a little different. Let's go description is a new sql.nullString. Why is that giving me trouble? Oh, because I'm doing it within the call to create post. Do it right here. Okay, so we'll create a new sql.nullString, and then we'll say if item.description does not equal the empty string, then we get to set description.string equal to item.description, and description.valid equals true. And then we'll use the description here. Does that make sense? So if the item's description is blank, then we'll set the value to null in the database, effectively. Otherwise, we'll create the valid description entity. Okay, next we need a published at. let's see, we've got an item dot pub date, which is a string. Okay, so we're gonna need to parse that string. To parse that date, there is a time.parse function in the standard library, and we're gonna use this RFC1123Z layout. So this is the layout that I'm using on the BootDev blog and on my blog. To be more robust and support all of the different publishing formats for all of the different blogs that we want to scrape, we'd probably need to make this logic a little bit more robust. But for now, I'm just going to say we're parsing it this way. If it's not that way, I guess we take a hike. Okay. If there's an error, so if error does not equal nil, we can say log.println couldn't parse date %v with error %v, and we'll pass in the actual pub date and an error, and that's going to be a printf. Oops. Cool. And then if that's an issue, we'll just continue. So if we don't get a valid time, then we'll just log it, log and move on. Okay, so published at, pass in that. I shouldn't use single name variables like this. Let's do pub at. Okay. What else do we got? A URL and a feed ID. So URL is just going to be the item.link. And feed ID, do we have access to the feed ID here? We do. We have the feed, right, because we passed in the feed here. Perfect. Feed.id. Now, db.createPost does return an error, so we need to handle that error. What am I screwing up here? Oh, it also returns the post itself. I don't think we care about the new post, though. I think all we care about is if it failed. So if error equal nil, failed to create post with error. Ooh, okay, let's give that a shot. Okay, build and run. Now remember, we're expecting this time to get logs that just say that the blogs were collected. So 21 posts from Lane's blog, 321 posts from the BootDev blog were collected. I'm gonna go ahead and kill the server, and let's check pgadmin. So now if we select star from posts, you should see a bunch of stuff in here. IDs, created at, titles, descriptions, published at dates. Awesome. This is looking fantastic. We scroll down to see how many rows there are, 342. That looks right to me. Now, I think we have an issue here. Let me show you what I mean. If we run this again, so remember, we've scraped both of the feeds and pulled in all of the posts. So if I rerun my server at this point, yeah, we're getting all of these issues. Failed to create post, duplicate key value, violates unique constraint, posts URL key. Right? Now this makes sense. We didn't want to store duplicate posts in our database, so we have a unique constraint on the post URL, which means when we go try to recreate the posts, it fails because we already have the posts in our database. So let's do a little string detection so that we don't log this crap every time this happens, because this isn't really an error. This is expected behavior. So we can do something like if strings.contains error.error duplicate e, then do we continue? What are we doing here? Yeah, then we continue. Otherwise, we'll log the error. So we're only going to log the error if it's not a duplicate key error. Okay, so let's run that again and make sure we don't get those errors. Perfect. We have one last feature to add to our RSS aggregator. We need a way for users to be able to get a list of all of the newest posts from the feeds that they're following. So we'll need a new query. We can call this one get posts for user, and it will return many posts. Now let's think about this query for a second. It's a little more complex than the other queries we've done in that I think we need to do a join. So we have our posts table, right? Posts have IDs, created at, updated at, but importantly, they have a feed ID. So we know what feed every post in the database belongs to. And we also have a feed follows table that tells us which feeds an individual user is following. So if we join those two tables together, right? If we take all of the feed follow information, kind of join it to the posts table, then we should be able to filter by all of the feeds that a user is actually following. So what does that look like? You can do select posts.star. So everything from the post table, from posts, join feed follows on post.feed ID equals feed follows.feed ID. Okay, so this adds essentially all the feed follow information to our, like, the virtual table for this query, right? We're joining those two tables together. So now we should be able to filter the way we want. Okay, so we've joined them together. Where where feed follows.user ID equals $1. Okay, so we join the tables and then we filter all the posts down, or rather the entire table, down by the specific user ID. So all of the posts that belong to feeds that the user is not following should, at this step, get trimmed out. Then we can order by, let's do post.published at descending. So give us the newest stuff first. And we'll limit by a configurable amount. So $2. Cool. Let's go ahead and try to generate that. Looks like it worked. Let's see if when we run the actual application, it does what we expect. Let's hook that query up to a new endpoint. So I'm here in the users file. That seems like a reasonable place. We'll do handler get posts for user. It will be an authenticated endpoint, so we'll need that user data. But here we're going to call API config.db.get posts for user. And then we can pass in the request.context and user.id. Oh, we also need, I think, a limit. Oh, sorry. We take database.get post for user params, right? Because we had multiple parameters here. So we'll need the user's ID and a limit. The user.id. And for now, let's just say a limit of 10. And that will return to us some posts and potentially an error. If we get an error, we'll respond with it. Couldn't get posts. Otherwise, we need to return the posts themselves. Now, we should go create a special posts model, right? So that we get our own tag. So type post struct. Go mostly copy this from our internal post model, wherever it ended up. Here it is. Okay. Add some JSON tags. Goodness, typing is hard. Now, here's an interesting thing. This SQL.nullString is not something that we're going to want to use in this struct, because this is a struct that marshals to JSON. The null string object is a nested struct. So if we marshaled it directly to JSON, we would actually get description as a JSON key, and then string as a JSON key, and then valid as a JSON key. So it'd be a little nested object there. That's pretty bad user experience because JSON natively supports kind of null in the sense that you can just omit the key or use like the actual value null. So what we're going to do is instead do a pointer to a string. And the way JSON marshalling in Go works is if you have a pointer to a string and it is nil, then it will marshal to what you'd expect in JSON land, which is that null value. Okay, and then publish that. URL and feed ID. Okay, did I miss anything? Let me look over this really quick. That's looking good. And next we need the conversion. So we'll do database post to post. Now this one gets a little hairy, right? We probably need to do some logic here. So we'll say var description pointer to a string. And then if db post dot description dot valid, then we'll set description equal to the address of db post dot description dot string. Cool. Then we can just directly use the description variable there. All right, publish that. What else we got? URL and feed ID. Okay. And last but not least, we need a way to do it, do the conversion for an entire slice. Func db or database posts to posts. And the logic will look pretty much identical to that, but I actually think it'll be easier to type it out. So we'll do posts, slice post. Database post, post. Pass in the database post. Okay. There we go. A lot of conversion logic there. But now we should be good to just respond with some JSON, and we can pass in those posts as database posts. Cool. What am I getting here? Struct literally uses unkeyed fields. Oh yeah, let's not do that. We want an ID, and I think it's a limit, right? What am I messing up? User ID. Perfect. Okay, let's build and run the server again. Oh, I realize I made a mistake. I need to actually hook this up to something. So let's go back into main.go. We need a new endpoint. We'll do get, I don't know, user feed. Now, feed's probably a loaded term in this application. We should say, let's just do posts. And it's going to require middleware. So middleware auth and API CFG dot handler get posts for user. Okay, so get slash posts. It's an authenticated endpoint. Perfect. All right. Let's rebuild and run that. Okay. Opening up Thunder Client. First, we need to check. Well, actually, let's just grab some auth information. So this clearly has some auth. Let's grab that API key. Create a new request. HTTP localhost v1 posts headers. Close that. Authorization API key. Okay, so if I make that request, I'm getting back no posts. Now we know we have posts in the database, but my user that I'm currently logged in as is not following anything. Right? I'm getting back the empty array when I check my feed follows. But I can check which feeds exist by running this API request. So let's grab this feed. Let's grab the Wags Lane feed, and let's go follow that one. So we'll post to feed follows here, this feed ID. Okay, so now I should be following. Let's check my feed follows. Great, I'm following them. So now if I go get my posts, there we go. I should just be getting posts from the wagslane.dev blog. Perfect. Let's try following the other one. So where is it? Feed follows? No, feeds. Let's try following the boot dev blog as well. So post to feed follows. Send that. Check my feed follows. Now I'm following both. Now if I go get my posts, perfect. We're seeing stuff from the boot dev blog. That's it. Thank you for sticking with me through all of this mess. We've created an amazing blog aggregator that will actually work pretty darn well at scale. You could run this thing, over a long period of time, collect millions of blog posts, and it would do pretty well. I hope you had a ton of fun with this project. I do want to remind you that this is a server, right? We've kind of been running it, stopping it, restarting it, but at the end of the day, you can just turn it on, add new feeds and follows and interact with it directly, and it will, once a minute, go out and collect all of those blog posts. So you could just keep this running on a Raspberry Pi in your house to aggregate, blog posts, podcasts, all that kind of stuff. I will point out that we have done a bit of happy path programming. So happy path programming is when you're not necessarily handling every edge case out there. You're handling kind of, the thing that you expect to happen most of the time. So for example, we only had one type of date parsing for the published at dates in our RSS feeds, but maybe there are RSS feeds out there that use a different date format and we'll fail to parse them. So one way that you could extend this project would be to just add a ton of new RSS feeds and make sure that you deal with the issues as they come up. Make sure you improve the logging so that you can see the issues when they come up. Anyways, I hope you had a ton of fun with this project and that you learned something. I just want to remind you that we do have an entire backend learning path over on boot.dev in Golang. So if you liked this project, if you liked this course and are looking for some more content, definitely go check out boot.dev. We also have published a lot of different ways that you could potentially extend this project to make it cooler. For example, maybe you add a front end or a command line application that interacts directly with the API so that you don't need to use a manual client like Thunder Client every time that you want to interact with your posts. And then I also just want to remind you before I go that you can find me on Twitter at wagslane or on YouTube at boot.dev. Definitely go subscribe to our YouTube channel as well. Thank you again to Free Code Camp for allowing us to publish this course and this project walkthrough. I hope you enjoyed it, and I'll see you in the next one.